Yes, so I am a professor in chemistry and in particular in bioorganic chemistry, which is a field between chemistry and biology. And what we are doing is we are preparing molecules that we can use to investigate the biological functions of cells, of multifunctional organisms. Yeah. And so I'm a professor at the University of Copenhagen, and in 2022 I received the Nobel Prize in Chemistry for what is called clic chemistry, which is a novel kind of chemistry where we can glue different molecules together so that they become one entity with multifunctions. So small molecular robots sticking together molecules with different functions. We can make a robot that can drive and brake and gas and so on. So you know, if we want to recognize the cell, if we want to enter into the cell, if we want to make an enzyme that can chew up something inside the cell, this is possible with clic chemistry. The Huisken reaction is something different actually. The Huisken reaction is a reaction between an acide and an alkyne. It doesn't have to be a terminal alkyne like in the clic reaction. It can be any alkyne, any acide. They react with each other and they are completely non-specific. They form a, undergo a 1,3 dipolar cycloaddition reaction, which is entirely different from the clic reaction. Because in the clic reaction, the alkyne is a very negative entity. There's a lot of electron density in it. So when we come with a positive ion of copper, it sits on this electron density in the alkyne. It acidifies it, and then it takes a place for the proton that sits on the end of the alkyne. That's why it has to be terminal. And this is not yet reactive, and second copper atom comes in, peels off the electron density, just like peeling off the lid of a can of sardines, and that gets you into the reactivity of the alkyne. So now the acide comes by with all its electron density. It's very electron rich. It binds to the copper and it injects the electrons into this reactive alkyne. Then it loses the copper atom and it forms this triazole. So it's two entirely different reactions. Yeah, so the first thing is that it takes time before other people learn about your chemistry, and it is an absolute requirement that other people start using your reactions, your chemistry, your novelty before it can really become applicable around the world like it is today. And so we actually, and the young people in my laboratory have done a tremendous effort to make this, realize this, you know, show that it's really useful to use this reaction in a variety of different scenarios. Gluing things together, stabilizing molecular structures, modifying surfaces. There's so many different areas where you can actually use this clic chemistry. Of course, I have two jobs now. I travel like I'm doing right now, on travel, and then I have my research and my teaching, which I'm very fond of and which I don't give up on. Oh, I think it's fantastic that you have these kind of prizes. I mean, the Nobel Prize itself is a good example of how much influence a prize can have. And I think these Jung prizes here in Spain are really important for Spanish science. And it's by the way that it's carried out, it also gives you a sensation that this is an important event, which means something for the scientists and for the community as such in Spain. Yes, it's a very good experience. I think that the organizers has made a very good format for this, And it's attractive, it's obviously attractive even to a lot of Nobel laureates to come here. And I think that the nominations that we get as judges for this, they are very, very amazing stuff actually, some of them are doing. And they're very well deserved, the winners of these prizes are very well deserved. Yeah, what I'm looking for at the moment is a better understanding of molecular interaction, because we are fairly good with understanding molecular structure. Within one molecule you have the atoms coming together, and we are pretty good at you know, determining mathematically how this works, and we can also determine experimentally that this is correct. But as soon as you have two large molecules that interact with each other, we are completely unable to make the calculation of how much they interact. Is this a good inhibitor? Is that a bad inhibitor? And so on. We don't know, because we cannot calculate it, and we have to do a lot of experiments in order to find the right compounds. I think there's something there we don't understand yet, even quantum mechanically, and I'm looking forward to see if I can figure that out. That's one thing, and the other thing that I think is very important is to understand catalysis or molecular transformations. So molecules can be transformed by chemical reactions that are carried out by catalysts, which can do things we cannot do without the catalyst. So you can do very specific reactions to transform one molecule into another functional molecule. And understanding this will actually allow us to go in and work with catalysis, for example in medicine, work with catalysis in environmental, solving our environmental problems. For example, degradation of plastics, or even carbon capture, and so on. Yeah, so I would say what I do say when I give public lectures is that you should understand that chemistry is everything. So you are actually a piece of chemistry, and if chemistry is everything, really is everything, is what the food you eat, it's the water you drink, it's you, it's everything around us, then that is the most important thing to learn. So we should actually teach our kids from first grade about chemistry, and we should do this in a competitive, pleasurable way, which they can actually get something out of, also entertainment-wise, because otherwise we will not be able to compete with all the gaming and all the things that are on the internet. So I think that we should make teaching or learning a pleasant experience, and we should do this by diving into the three-dimensional world of chemistry. It's really very exciting what you as a scientist have in your head, and the way that you can see it and understand it in your mind is really very exciting. And I think we could actually, by using animations, we could actually transform this understanding into something really entertaining for the kids, giving the molecules personality, colors, all sorts of things that would inspire the young to actually understand and maybe give thoughts, just to give thoughts to the chemistry. Yes, I love to play music, and I actually have a band. I had a band until I got a Nobel Prize. It's been very hard to find the time to get together and play music. So I play the guitar together with another guitar player in this band. There's a drummer, there's a bass, and there's a pianist, keyboard player, and then there's a singer. So we play all sorts of music, and it's very nice. I also make some music myself, and I really like that. So before I go to bed, often I play for half an hour, put on some music and just improvise. No, I have a lot of friends which are not scientists. Actually, when I was very young, all my friends became architects, and I was also looking at becoming an architect. But then, you know, there was chemistry, and when I was very young, I was always interested in evolution, in chemistry, and what is that compose this beautiful world that we are living in. I was very privileged to have a grandfather with a big farm in one of the islands in Denmark. So I went there in all my holidays and had this very intimate interaction with nature. And got the idea that chemistry was the thing that could explain this nature, how it works, how things are interacting, and why it's so harmonious. So I was always interested in chemistry. So when my friends wanted to become architects, I thought, what can I do? And I chose to become an engineer. And during this process, I was almost choosing to become an IT engineer. But chemistry won, and I'm happy today. Yes, don't be concerned with your ambitions for Nobel Prizes or even higher salaries. Just concern yourself with your problems in the fume hood, in the lab, because that's where all the challenges, all the rewards are coming from. So when you fall asleep at night, dream about solving the problems of tomorrow.